Okay, let's look at solving radical equations, the second part here, where basically the same set of steps, but now they've added radicals on both sides, or square roots on both sides, and as in the case of number 1. So there's nothing else. We have both sides isolated with square roots, so I'm going to go ahead and square both sides. And this one we get rid of. Square root, we have 3x plus 1 equals x plus 15. And we just solve this simple algebra problem. So we're going to subtract x and get 2x. And we're going to minus this 1. Bring it over here. So that would be 14. Divide both sides by 2. And x equals 7. So just like in the cases before, we need to verify these answers and make sure there's nothing extraneous or a non-valid answer. So take the square root of 3 times 7 plus 1 and set it equal to x plus 15. And we have 21. 3 times 7 plus 1 is 22. And on the right, 7 plus 15 is 22. So it looks like we have equivalent statements, so this checks out. And the solution is x equals 7. Alright, let's take a look at number 2. Number 2 involves, looks like a cube root. And right now they're not on separate sides of the equal sign, so let's go ahead and move over one of these. In fact, this quantity is minus, so if I add it to both sides, I would just end up with 9x to the third root equal to positive x minus 24, and that's the third root as well. And we'll just raise both sides up to the third power, canceling out the cube root. And we'll get 9x is equal to x minus 24. So I'll subtract an x, and get a positive 8x equals a negative 24. And divide both sides by 8. And looks like we get x equals negative 3. And let's go ahead and verify that again. The cube root of 9 times 3 is going to be 27 on the left, and on the right we have a negative, oops, that's a negative 3, sorry. It's a negative 3 right there, and we have negative 3 minus 24. And so we get the cube, we get the cube root of a negative 27 equal the cube root of negative 27. Of course, if we went ahead and solve that, this would equal negative 3, and the right side is equal to negative 3. So negative 3 is our solution. All right, let's take a look at number 3, and it's a little bit different. Could be a little bit tricky, but we've had some practice on this a day or two ago. So remember, the first step is to isolate the radical, and right now the radical is not the only thing on the left side. We have 5 plus the square root, so let's get rid of this 5 by subtracting 5. And of course you can't, these are not like terms, but we can just rewrite it. We have the square root of x plus 7, and this is equal to x minus 5. And now we have to square both sides, and this is got to be real careful right here. Remember, you're wrapping up the right side because you're going to square the entire quantity x minus 5. So here the left side becomes pretty easy. It's just x plus 7, and hopefully you're getting good at the shortcut. We have a binomial being squared, right? So you square the first, multiply the two inside terms together to get a negative 5x, and then multiply that by that 2, or double it, and we get a negative 10x. And then squaring the negative 5, we get plus 25. So now this looks a lot different than the two we did before, but we're going to have to see if we can factor this out here in a second. So let's go ahead and combine like terms. So we're going to subtract an x, and we're going to subtract an x from the 10x that we had. And let's go ahead and subtract our constants. We have plus 7, and we're going to subtract 7 here. Let me rewrite it over here in green. So we would have on the left side 0 is equal to x squared, and we have a negative 11x, and 25 subtract 7 is going to take us to what? 18, positive 18. Okay, so we're going to have to factor this one. And so remember, if we use crisscross, since the leading coefficient is 1, we simply multiply to get 18. So we're looking to multiply to get 18. And we also need to add to get the negative 11. And so it looks like we can use a negative 9 times negative 2. That multiplies to get positive 18. And adds to get negative 11. So this looks like x minus 9 and x minus 2 equals 0. So what does that solution give us? It gives us that x equals 9 is a potential solution and x equals 2 is a potential solution. Well, this problem seems like it's a little bit long because now we have to actually check it to see if both these solutions are valid. So let's go ahead and do that over here. I'll test the positive 9 out first. Let's see here. So I'm going to plug in positive 9 for that x right there. We have 5 plus the square root of 9 plus 7. And it needs to equal 9 because that's x. So 9 plus 7 on the inside right here is 16, and the square root of 16 is 4. We're going to add 5 to that, and it looks like this one's going to work out just fine. 5 plus 4 does in fact equal 9, so that checks out. Go ahead and record that solution up here in the box. X equals 9. And let me erase this area right here and use that to check the second solution. So I'll do this one in red. We're now going to test x equals 2. So we have, okay, we have 5 plus the square root of 2 plus 7 equals 2. Alright, and let's see. We have 5 plus 2 and 7 added together is 9 equals 2. 5 plus 3 equals 2. And that is not true. Of course, 8 certainly does not equal 2. So we just have one solution, even though we had an extraneous one here. So anyway, I will stop this here and let you try the last one, and you should be able to get tackling on your homework.